How many of you know what Zuul is? Okay, that half of the room. And Robert. Great, and how many of you saw something like this talk last year? All right, excellent. My name is James Blair. I work for the OpenStack Foundation, and I'm a core member of the infrastructure team for the project. Which means that I and the other members of the team that I'm on are responsible for all of the systems that the developers use when working on the OpenStack project, aside from their own systems, and the continuous integration infrastructure for the OpenStack project. This is not a talk about OpenStack. There were quite a few of those already at this conference. What it is a little bit about our development process so that you get a background about what we're doing, why we're doing it. It's about a process that we call Project Gating, which is like continuous integration, but it's done backwards. And specifically about a program called Zuul, which we use to actually accomplish that. And finally, we're going to talk a little bit about some of the directions that we're heading with Zuul in the future. So as I said, this isn't to talk about OpenStack. So really quickly, I'll talk about OpenStack. It is open source software for building public and private clouds. So if you if the Rackspace Public Cloud, HP Public Cloud both run on this software. You guys probably know what infrastructure as a service and cloud computing are. But basically, you can get compute nodes, networking setups, block and object storage, and the like, all on demand with some API calls. OpenStack is one project that's created, that has a lot of component projects that make it up. So there's a component to manage compute allocation, storage, networking, identity management, etc. So each of these projects is its own Git repository with its own developer community. And but at the end of the day, we have to take every one of these, put them together, and end up with something that looks like a coherent and working system. So as I mentioned, there's a pretty diverse development community overall, as well as working on each of the individual projects. You can get a rough idea of what we're dealing with here with contributors from lots of major corporations, all working on the project ideally together. Basically, a lot of the challenges that we deal with are related to the fact that we have this massively distributed developer community, and we're trying to facilitate the operation of the project as a whole for all of these people. One of the things that we do to try to accomplish that is to use consistent tooling. So centrally, we run this continuous integration system that all of the patches to all the projects get run through. And we have a number of other tools that we've built out as well to manage Jenkins configurations, to help developers submit changes for code review and things like that. But one of the biggest things that we do to facilitate developers working together and producing something that functions is project gating. So this is the idea that before any change lands to any of the Git repositories, it has to pass all of the tests that we have for the project as a whole. The reason for this is, one, it's to make sure that OpenStack actually works. it's a very complicated system, and it's pretty easy to make a change that, due to the interaction of all of these different parts, would cause it to break. And just the little bit that you're working on might still work, but as a whole, it might stop working. So it's to make sure that we always have working code in the repository. So, and again, if you have as many developers as we do, if you have a few hundred developers who all check out they get up in the morning, they check out the latest copy of the repository, it would be really great if that worked. So Project Gating helps ensure that. It means that when you start your work, you're ideally not fixing the bug that somebody else committed last night. And it makes it egalitarian. We have nobody in the project can just merge a change and bypass this test system. Every change for every project submitted by anyone goes through the same code review and the same gating system to make sure that change passes all of its tests before it lands in trunk or lands in the Git repository. I'm going to say trunk occasionally because we used to use Bazaar, and some of that terminology sticks with you. Everything is automated. We hate doing work by hand. We have computers to do it for us. So all of this testing is automated. All of our release process is automated. You can actually, this is kind of a teaser for the main status screen for Zuul, and you can already get an idea that not only are we running a lot of tests, but we have facilities to manage documentation builds and release artifacts and things like that, which I'll get into later. But I'm sorry?
It'd be nice if the gate was that small, apparently.
Well, right, yeah. Well, even now it goes off the screen a bit, but yeah, I'll show the real one in a minute, and the numbers are larger right at this moment. So really quickly, the process flow for a developer is it's a fairly typical Git process flow, but we have a couple of unique aspects to it. So you start by cloning a copy of, so Nova is the code name for our compute system. So if you're going to work on Nova, you start by cloning a copy of the Nova Git repository into your local environment. We recommend all of our developers use a branching model when they're working. So create a new branch off of master. Say if you're fixing a bug, you write that fix and you commit to your local branch. Ideally, you run tests, but honestly, we have this huge system for running tests, so a lot of developers figure why bother, and they just commit it and throw it at it and see what happens. So anyway, once it's committed, you can run a program called git review, which is a git subcommand that we wrote for dealing with Garrett, our code review system, which I'll talk about in a minute. But at any rate, this simple command takes your commit and sends it up to Garrett for code review. And that's really all there is to it as far as what you have to do locally. So it's actually a pretty lightweight process to interact with all the machinery that I'm going to talk about. Once it's on Garrett, developers review it, and Jenkins via Zuul is going to test your change and report whether or not it works. If it doesn't, or if the developers don't like it, you should probably change it and amend your commit, push it back up again, go through the process again. Once Jenkins and the core reviewers like a change, they can approve it for merging. Then it goes through one last round of testing, and this is what we call the gating process. This is where right before the change lands in the repository, we test it one more time. Basically, because this process might have taken a while. It might have taken a couple of hours, it might have taken a couple of weeks. Either way, the velocity on the project as a whole is so great that the test results that we had when you uploaded your change are frankly irrelevant now. We can't trust that it's still going to work, even though it worked 3 hours ago. So the gating system makes sure that when that change actually is about to land, it's really going to work. If it does, it ends up in the Git repository. So Gerrit, as you saw from the previous slide, is pretty important to this process. It's a standalone code review system written by Google for the Android open source project, and it seems to be increasing in adoption with a lot of open source projects. Some of them aren't even at Google. It is really flexible, which is one of the reasons we like it. It has, you can do queries against it and get information out of it with JSON. It has hook points, and it has this really nifty event stream where you can SSH into it, and it just spits out little blobs of JSON at you, telling you everything that's going on. So it's very extensible and easy to hook into all of the automation that we have. It also has extensible review categories. So not only are individuals able to vote on a change and say that they do or do not like a change, but also automated systems can leave comments indicating that they've verified that something works. You could add a column that says, I've done a license check on this change and it's okay. Or the copyright assignment is all in order, or whatever you want. It's very flexible. So the life cycle of a patch is, if you think back to that diagram, once you've submitted a code for review, we run the tests on it. Our systems decide whether or not it's verified. Core reviewers review the code for correctness and desirability and things like that. Anybody can actually log into our Gerrit and start reviewing patches. You can do that during this talk if you want, actually. But we have teams of core reviewers for every project, which are people who are really involved in it and have shown that they understand what's going on. And those core reviewers are the ones who get to decide finally whether a patch is going to go in or not. Once they've approved a change, then the testing that I talked about goes into operation, and then the patch is merged. All of these points that I talked about, Gerrit provides hook points there. It provides events for all of these states that we can trigger actions off of. So whenever somebody uploads a patch, it emits a patch set uploaded event. There's a change merged event. Whenever somebody leaves a comment or leaves a review vote, that emits an event as well. And finally, if somebody pushes a tag or if any of the branch refs in Git are updated, it emits events for that as well. So we can use all of these, and Zuul or even other systems can perform actions based on those. So as a developer, this is what the result of the test system looks like. So when you've submitted a change, you can see there's actually a lot of comments up there from real people. People with names like Johannes and John are real. Things with names like Smokestack and Jenkins are not. Anyway, at the bottom you can see how Jenkins reports its results back to Gerrit, and each of those job names here is a link to the logs, and then of course over on the right we have whether or not that the job was successful. So developers can come back and they can see in this case that the dev stack test for their change failed, and so they can click here and go look at the logs and ideally figure out why. So we use Jenkins to run our tests. We run a few different types of jobs in Jenkins. There's the gate tests, which are the things that I just showed you that decide whether or not something is working and able to merge. After we merge a change, we have some automation that builds docs and publishes them to docs.openstack.org. We build tarballs and publish them to tarballs.openstack.org. And for our Python projects, we upload Python packages to PyPy automatically as well. We have a couple of different ways to work on jobs while they're in the development phase. We have a system to create experimental jobs so that people can say, well, I want to start testing Nova with Postgres. So I'm going to write a job that does that, but I don't actually want to bother any other developers yet. So they can do that in this system as well. When that starts to work at all, really, we can move a job into a silent configuration so that it runs quite a lot, but still doesn't report anything back. So you can collect data on what does this look like when we run it all the time. And then finally, when we're about ready to actually expose a job to developers, we can put it in a non-voting mode where it runs and reports its result back. But even if it fails, it's still not going to block anything. So that increases the visibility and gets it out in front of developers. And finally, we have periodic jobs, jobs that we run every night. So these are we check our stable branches for bit rot because they might have not seen a change merged in a while. We update images that we use, and we run some very long tests that we can't run in the gating system. So the engine that we use to drive all of this is called Zuul, and it's something that we wrote within the OpenStack Infrastructure project. And it interfaces with Gerrit and Jenkins or other systems, and I'll talk about that in a bit. It's very flexible. It allows for a lot of different kinds of project automation. Some of the things that I just talked about are things that we actually didn't even anticipate when we wrote Zuul. We just found that because we didn't build in too many assumptions about what we were going to do with it, we found we could do a lot of things with it. It allows parallel testing of serialized changes. I'm going to really dig into that in a minute, but that's basically how we're able to test every single change to the project and still keep up some kind of a velocity. So basically, ideally, what we would like to do with the project is somebody approves a change, and then we test it, and then we merge it. And we do that one at a time, one after another, as people approve changes. It's fairly easy to wrap your head around that, and you could see why, if you do that, you'll end up with a project that never breaks, that always passes tests. But our tests take about 40 minutes, 45, 50 minutes to run. That varies depending on, a number of different factors. But so you could see that, say, on the order of an hour, if your tests take on the order of an hour, then you could only merge 24 changes in a day. And you saw how many projects we have. And so that's clearly not going to work with any kind of velocity. So we sort of took a page from Pentium processor design, right, and looked into speculative execution, where we could say, well, let's test this. We'll test the first change, and then we'll start testing the change after that, with the assumption that the first change is going to pass all of its tests. And you can keep doing that, and you can keep stacking the changes one on top of the other. And as long as all of the changes end up passing, then this sort of future you've predicted, where each of those changes is going to merge, will come to pass, and everything's fine. As it turns out, if one of those changes fails, then your prediction is wrong, and you have to discard the work that you've done and recalculate it. So for those visual people like I am, I've got a little sort of illustration of how this works. So if you have two projects, say Nova and Keystone, And these little dots here represent the head of the Git repositories for each of those. And then somebody comes along and starts approving some changes. So somebody says, I'm ready to merge change number 1 to Nova. And then somebody says, I'm ready to merge change number 2 to Nova. And then somebody approves the change to Keystone, and then finally another change to Nova, right? So you've got these 4 changes that have all been approved, and they all need to merge into these Git repositories. So what Zuul does is it queues them up in order as people submit them. And you'll notice that Keystone and Nova are both in this queue. And that's because, like I said earlier, these projects all have to work together. So it's possible to merge a change to Keystone that breaks Nova. So that means that if you're going to test these changes, you need to test them all together. And so Zuul actually automatically identifies which projects have these relationships with each other based on the fact that they share a test in Jenkins. And so it forms them into a single queue where all of the changes are lined up for testing. So basically, as soon as these changes are queued, Zuul starts telling Jenkins to start running tests for them. So as you can see, they all went in about the same time. They all started running tests about the same time, and they might have finished at different times, but they're all finished now. Then Zuul looks at the results for each of those changes, and it sees that change number 3 failed its test, right? So number 4 was queued behind change number 3, which means that when number 4 was running, it was testing Nova with the Nova repository with changes 1, 2, and 4 applied. And it was also testing Keystone with change number 3 applied. So it was testing that change with the assumption that every change ahead of it was going to pass. But it didn't. Change number 3 failed. So at that point, the results that it had for 4 are no longer valid. So it cancels any jobs that are still running and discards those results. And it reorders the queue. So 3 is still behind number 2 because no other changes have failed ahead of it. But 4 gets re-enqueued behind number 2 because that's the most recent, the nearest change ahead of it that hasn't failed. And so Zuul then restarts the changes for number 4. This time, the tests for number 4 pass. So that probably illustrates the fact that number 4 was broken because number 3 was broken. So you can see that at this point, the best thing to do is to just kick 3 out of the queue, send it back to the developer and say, hey, something went wrong, you need to fix your patch.
When one of the long-running things fails, does that mean the patch after it sort of maybe like 90% of the way through its run and something ahead of it's failed, so it goes, right, discard and move?
Yes.
Right.
Yeah.
So that means that you could potentially have a patch that is always stuck behind something that is going to fail as it moves off the tree.
Yes. Okay. So to repeat the question, it was that if you have a patch that's failing, like for instance Keystone number 3 here, as that moves up the tree, won't the changes that are behind it keep getting canceled and discarded? And in this case, Zuul is doing extra work. And the answer is yes, that is the case. Ideally, changes don't move up the tree in the way that you're discussing.
The Nova 4 sort of did because it's skipping past.
Yes, it did, right? But at this point, 3 is out of consideration. Zuul has decided it's not going to merge, so it's not going to put any more tests behind it. So at this point, at least in this illustration, 3 isn't going to affect anything behind it anymore. It had a chance once, and it screwed up. And so it doesn't get another chance for a while. There are conditions where it could have another chance, but at least for the purposes of this illustration, it doesn't in this case. So it's out of commission and time to move on. And there's another question in the back.
Yeah, so similar kind of question. So because the runtimes are a little variable, presumably you can get a case where, say, 3 has failed, but 2 is still running.
Yes.
And so in that case, would Nova, say, 4 still getting queued behind 2, which is still in progress?
Yes. So the question was, because the times are variable, presumably a change further down in the queue could finish before a change ahead of it has finished running tests. And the answer is yes, that happens. And in this case, if 2 were still running its tests, number 4 would be in-queued behind 2. So it's being as optimistic as possible. It's assuming that anything that hasn't failed yet is succeeding. So now change number 1 has passed all of its tests. It's at the head of the queue, so it gets to merge. Change number 2 is now at the head of the queue. There's nothing ahead of it, and it's passed, so it gets to merge. Change number 3 is still sticking around basically because of the thing that you just said. There's a possibility that 3 might have failed because 2 was about to fail. It didn't happen in this case, but if 2 were still running and 3 had failed, Zuul's going to keep 3 around just in case it decides that it actually has to restart 3 because 2 failed. But that didn't happen. 3 is now at the head of the queue, and it has failed, so we just discard it. And finally, 4 is at the head of the queue, and it can merge. So we have a concept that's pretty central to Zuul is the idea of a pipeline. Each of these changes gets enqueued into a pipeline, and we have a number of different pipelines defined for OpenStack. Let me actually just switch over to the actual status page real quick. So you can see in the check pipeline right now, there's a whole bunch of tests running. There's the gate pipeline, which of course is the thing that I just described. I'll talk about why this looks so weird in just a minute. There's the post pipeline, which happens when once a job merges, changes end up in the post pipeline to do things like build docs and whatnot. Whenever something gets tagged, it shows up in the tag pipeline. These things build release artifacts and publish them. There's the silent pipeline, which runs jobs that we don't want anybody to see. The experimental pipeline, it's similar. It runs jobs that aren't ready for prime time yet, but they do actually report back in a non-voting manner. And then finally, the periodic jobs that we run once a night or so. And actually, you can see there's a little bit of a relationship here between the animation that I just showed and what the queue actually looks like. And the reason why it looks so weird right now is because Zuul is actually, as we speak, in the middle of a reset, and it's reordering the changes. And while I managed to get this looking right on an HTML page most of the time, occasionally when a reset is happening, it's a little, getting all of the lines to point to the right place without crossing each other is a little difficult. But at any rate, this is about as far down as it's gotten right now, and it's reordering these changes. We're coming up on a milestone release for OpenStack, and a lot of people are in a rush to get changes in. They've basically procrastinated until the last minute. They took time off at the end of last month, which is hard to believe. But now they're all back and trying to get their changes in before this milestone, which is why the queue is currently 71 changes deep. But you can see we've got these little sparkline graphs that show it was actually deeper earlier, and then a whole bunch of changes merged at once, and it got shallower. So anyway, these are all of the different pipelines that we have running now. So Zuul is configured using what I hope is a fairly readable YAML configuration file. And this is where a lot of the flexibility that I talked about earlier comes in. It doesn't know the difference between a check pipeline and a gate pipeline and a experimental pipeline or things like that. Those are all ideas that we're using really basic primitives and building up these conceptual ideas out of it. So our definition for the check pipeline basically looks almost exactly like this, which is we're defining a pipeline. Its name is check. The independent pipeline manager is probably the closest we get to building some of these ideas into Zuul. That's basically just telling Zuul that the changes have no relationship to each other. It's saying, don't do that thing where you order the changes and do the speculative execution. This is just run tests for all of these as fast as you can. Every time a patch is created in Garrett, that change should be enqueued into this pipeline. And if the jobs succeed, then you should report back to Garrett with a verified 1 vote. If they fail, report back with a verified -1. And then finally, the precedents up there, we actually have a couple of different queues. And so you can specify that changes in this pipeline have a low, medium, or high precedence. So the jobs can jump to the front of the queue if you need. The gate pipeline is very similar, except that it has a couple of extra things. First of all, it's triggered on a comment added event in Garrett, where somebody leaves an approved vote. So the actual thing that causes Zuul to enqueue this change is somebody leaving an approved vote in the approved review category. And when it starts, it reports that to Garrett because we like to actually have a little bit of feedback to users saying, yes, this is being enqueued. And it clears out any previous votes that Zuul might have left, perhaps in the check pipeline. And then finally, if the changes succeed, then not only does it vote with a verified ±2, which is like a verified ±1, but more so, but it also tells Garrett to submit the change. Submit is Garrett speak for actually perform this merge. The post-merge pipeline, again, is very similar. We're back to the,
Yeah, I've got a question
Yeah.
about that. Is that your actual config?
This is really,
Simplified.
it's fairly close. I'll show you the question is this the actual config? The actual config has a longer description that doesn't fit on the slide. We have an extra thing that lets you trigger something with a recheck or re-verify comment. But other than that, that's basically it. All right. And the other thing I didn't mention is here we say it's a dependent pipeline manager because this time we do want Zuul to do the thing where it queues changes up and does the speculative execution work. So in post, we're back to independent pipelines, where basically when there's a ref updated event from Garrett that matches this regular expression, that means that something has merged to a branch. And in that case, we want to build the documentation for that branch and build a branch tip tarball as well. Experimental pipeline, again, this is something that we just came up with out of and built out of these primitives that we already had. Here, the trigger is somebody actually leaving a comment, and this is like the thing that I glossed over in the gate pipeline. So if somebody leaves a comment with the words check experimental in it, then that means that Zuul will enqueue the changes in the experimental pipeline. So basically, this means that it's now an on-demand pipeline. It's an easy way for developers to request that changes, that tests run for this particular change, but otherwise they won't run. And when it reports back to Garrett, it doesn't vote. All it does is actually just leaves a message in Garrett.
That one doesn't have a manager, a pipeline manager.
Oh,
Is that in the defaults? Or
yeah, then the question is, hey, it doesn't have a manager, and probably the answer is I simplified it too much on this slide. So, yes, it really should have a manager.
That's probably small.
Yep, there it is. It's got one. I think Zuul even now has syntax checking. So if I ran this through Zuul, it should actually tell me like, hey, you kind of need a manager. The silent pipeline, like I mentioned earlier, it just runs anytime a patch is uploaded, but then it doesn't report at all. So basically what we're going to do here is go and find the results ourselves manually some way, or just look at aggregate results. Like Zuul will send statistics to Graphite via statsd, so we can go look at the graph for a change and see like, oh, well this, or sorry, the graph for a test, and we can see that this test always fails, so it's clearly not ready for prime time yet. Here's our release pipelines. The regular expression gets a little bit more complicated because we're writing Python, and so of course the regular expression for a final Python version number runs off the screen. But basically what this is looking for is somebody pushing a tag that looks like a version number. And so whenever somebody tags the repository and pushes that, then we start building a release based on that. And we actually have some really nifty automation that means that you don't have to do things like commit version numbers to your repository. We actually just build the project with the tag that you've pushed as the version. And all of that's triggered by this. Our periodic pipeline is basically, it just runs on a timer. So early every morning we kick off a bunch of jobs. It's recently, thanks to Joshua Hesketh, grown the ability to send email. It hasn't grown the ability to read email, which means it's not, as a program, it's not feature complete yet. But it can send email. And so this is actually what we're doing now as of a couple weeks ago. We stopped using Jenkins' ability to send mail because what it would do is send you a piece of mail that said, this job failed. And then it would send you a couple hundred lines out of the 10,000 lines of output from that job, which basically was more or less context-free. That's pretty useless to get something like that in email. And then it would do that for every job that failed. So you'd end up with a bunch of emails. Here, with this, what we get is an email that looks almost exactly like what I showed you in Garrett with the list of jobs that have run, whether they succeeded or failed, and those, and then clickable links to the logs for all of this. So you get a summary report every day of all of the jobs that run. So I think it's a lot more useful for folks like our stable branch maintainers.
So Zuul queues that up because the time looks suspiciously like a cron timestamp.
Yes. It's not actually using cron, it's just using the syntax. So the question was does Zuul do this? And I think the implication was, or are we just passing that to cron? And the answer is that Zuul is doing it. We just use the cron syntax because everybody knows it, or knows where the man page is. Actually, probably, I don't know. I don't know it, I admit, I just know where the man page is. So anyway, I've already shown you our actual full Zuul configuration, well, actually, I didn't show you this part. So this is how we actually configure a project. So for instance, for Nova, we've got all of these pipelines that I mentioned earlier. And then we just say, whenever a change for Nova gets enqueued in one of these pipelines, run these jobs. So whenever somebody uploads a patch set for Nova, that's going to hit the check pipeline. So it's going to run the PEP8, the docs, and the Python 2.7 jobs, and then the Tempest dev stack job. It's actually quite a bit longer than this, so at this point we run a lot of jobs, but this gives you the general flavor. And then we just repeat this for all of the projects that we have. There's a templating system in the configuration file as well, so if you're running a project with 20 projects that all behave about the same, you can template some of this stuff out and avoid repetition. And as I mentioned earlier, projects that share a job automatically get a shared change queue. So here we've got two projects, Nova and Glance, and because they share the Gate Tempest DevStack VM job, that means that Nova is going to combine those into a shared queue. If they didn't, then actually their gates would be separate, and a change to Glance wouldn't have to wait for a change to Nova to merge. I've already shown you the status view. So one of the things we've done recently with Zuul is to make it so that it's not quite as tightly tied to Jenkins as it was originally. So you can actually use Gearman, which is a fairly simple job distribution system. It's a very lightweight protocol. And you can have Zuul basically submit requests to Gearman. It puts jobs on the Gearman queue, and then something on the other end can pick up those jobs. We have a Gearman plugin for Jenkins, so that means our Jenkins uses Gearman to pick up these jobs and run them. But you can, it's a pretty simple protocol. You can write your own worker. You can use something called Turbo Hipster, which Joshua Hesketh wrote, and Michael claims credit for when he speaks about it at conferences. And they're actually using it with a Zuul to run the database migration tests for Nova. So anyway, Zuul is becoming agnostic about what runs its jobs. It just cares that they get run. And yeah, so it's basically, it's pretty easy to hook up anything to the other end of Zuul. There's as you might have sort of inferred, there are now two reporters for Zuul. There's reporting back to Garrett, and then there's reporting over email. This is also a pluggable thing, so if you have something else you would like to report to, I don't know, report over SMS or to, I don't know, some other project management website that people may or may not use, that's also a pluggable system, so you can write something that hooks into that. The triggers are pluggable as well. We have two triggers, the Garrett trigger and the timer trigger. But again, that's something that you could integrate with other systems if you felt the need. And people have expressed interest in integrating this with GitHub, but it hasn't been written yet. If you'd like to, we'd certainly accept that patch. In case it needs saying, this is all free software. It's under the Apache license. You can get it from get.openstack.org. It's got bugs on Launchpad, docs on our docs site. We hang out in the OpenStack Infra channel on Freenode, and we love to talk about this stuff. And there's a mailing list that you can subscribe to as well. And these slides are available at a better URL than this. Oops. Anyway, they're at docs.openstack.org/infra/publications. So I think we might have just a little bit of time for questions, if there are any that didn't get answered already. All right, cool, thanks. Oh, sorry. Oh, yes. Why Zuul? Because it's a gatekeeper.
Does it look like
Oh, Joshua.
Have you given much thought to a multi-master Zuul?
Have I given much thought to a multi-master Zuul? Yes, I have given that some thought. The complicated thing is that its main function is around making decisions, and so distributing decision making about a single entity is a complicated problem. I think it's probably doable, but I think there are actually other things that we can do to deal with scaling in the short term, and one of those I actually just published to the mailing list about moving a lot of the work that Zuul does out into workers, so it's strictly decision making. That at least gets us very far down the road in terms of scalability. You still might want multi-master Zuul for HA reasons or things like that, but we run it on the cloud, and of course the cloud is always up. So. Do we have any more time? If so, question in the back?
So just, do you know if anyone looked at doing a basic post trigger? So just triggering off a HTTP post?
I don't believe anybody has, I haven't heard about anybody expressing interest in that. I think it's possible and we could probably accept it. Zuul already runs a tiny web server just to serve the status information. If it starts doing anything more than spitting out read-only JSON, it might need to actually start using a real web server with a real Python web framework. So.
You can trigger with the Gearman protocol.
Oh, yes.
Oh, so Gearman can go in? Yeah.
Modern Zuuls come with a command line client that will let you trigger on the command line.
So the reason I brought up the post question was because of the comment about GitHub earlier. And so GitHub, Bitbucket, all of those, one of the easiest things to set up for integration from them is just the post hook on your repo, where it will go hit the URL with whatever payload you tell it to send.
Yep.
And so it becomes one of those things. If you can accept incoming posts, you can kind of trigger off most of those repos. Anyway, just an idea.
Yeah, thank you.
Well, thank you very much, James. It's